Okay, cathode ray oscilloscope. Let's start from thermionic emissions. Thermionic emissions. Now, what is thermionic emissions? Now, to understand thermionic emissions, we need to go back to what you have learned. So, thermionic emissions come from the words thermal, ion. Thermal means heat. Thermal. This means heat. Okay. Ion, you know, is a charge carrier, right? Ion is a charge carrier. And in this case, the charge carrier is the electrons. So what is thermionic emission? Thermionic emission is a process of emissions of charged particles. Okay, and the charged particle is known as a thermion. Actually, it's electrons. It's electrons. So emissions of charged particles from the surface of a heated metals. You heat the metals, it will release up to a certain temperature. It will release some charged particles, and this process is called thermionic emissions. And the charged particles normally are electrons. So, for examples, we have these hot filaments. We use electricity to heat these filaments, and up to certain temperatures, electrons will be released from this hot filament. Okay, and this is called thermionic emissions. Temperatures of metals. When the temperatures of the metal increase, the emission rate of electron will increase. This sounds reasonable. It's because when the temperature is high, then some more electrons can jump out from the atoms. Okay, so let's say this is a shell. Okay, so more electrons can jump out if the temperature is high, because when temperature is high, more heat energy is supplied to the electrons. When the electron absorb the heat, it will jump out from the shell, jump to the higher levels. Okay, jump out, jump, and then after that, it will jump out from the atoms. So this sounds reasonable. Higher temperature, more electrons release. Surface area. So let's say we have two pieces of metal. One is small, another one is big. So the small one can release electron, and the big one, of course, the big one can release more electron if heated, right? Okay, if it has a bigger surface area, then more electrons can be emitted compared to a small area. Okay, so surface area increase, the rate of emission also increase. Okay. Type of metal, I think I explained to you just now, right? When we compare lithium and sodium, okay, then you will find that sodium can release electrons easier compared to lithium, because the attraction force between the valence electron and the nucleus is weaker. Okay, surface of metals. Why we want to coat a metals? We want to coat a metal with another materials. Okay. For example, barium oxide and strontium oxide. Now, barium oxide and strontium oxide, it can release electrons easier. Okay, barium oxide and strontium oxide, it can release electrons easier. Then why not we just straight away use barium oxide? We can use a piece of barium oxide, okay? A piece of barium oxide, and then it can just release electrons, because it can release electrons easier, right? But the problem is, if you use barium oxide, it's very difficult for us to heat barium oxide, because barium oxide is not metals. It cannot conduct electricity. Okay, so it's very hard for us to heat barium oxide, and the temperature also increase very slow because the specific heat capacity is high. So therefore, the temperature will increase very slow. Okay, so it's not practical for us to have a piece of barium oxide as the emitter. Okay, normally what we do is we have a filament. This filament, when there's a current flow, the temperature can increase very fast. So that's the functions of the filament. Okay, the filament is to increase the temperature at a very short time. So when there's a current flow, the temperatures of the filaments will increase very fast. But the problem is, these filaments, the temperature can increase very fast and increase until very high, but it's very hard for the filaments to release electrons. So the filament cannot release a lot of electrons. So therefore, in front of these filaments, we will put a piece of metals. We will put a piece of metals. This is the metals can release electrons very fast, okay, and the temperature can also release very fast. But if you connect the electricity to these metals, the temperatures of the metals will not increase very high, okay. But this one, when you connect to electricity, the temperature can increase to a very high temperature. But this one, no. So we use this filament to heat these metals. This filament to heat this metal. This metal can release electrons easily, but the temperature, when you connect to electricity, okay, the temperature won't increase very high. But this one, the temperature can increase very high, okay. But still, the electron they release is not enough, okay. It's not enough for certain purposes. So therefore, we coat it. We coat these metals with barium oxide or strontium oxide. On the surface, we coat it with barium oxide and strontium oxide. Now, barium and strontium oxide can release electrons very fast. So the function of the filament is to increase the temperature up to a very high temperature. And these metals is heated by the filament, and it can supply electrons. It can supply electrons. And the strontium oxide or the barium oxides on the surface is used because they can release a lot of electrons.